Hello everyone, I'm back with a new tutorial about machine learning. In this tutorial, I'm going to discuss about gradient descent or cost function. Before starting this tutorial, please subscribe my channel to benefit lots of project about simulation, Python script, and machine learning. In this, as I told already, I'm going to write our own code about gradient descent. What is the gradient descent? Gradient descent is an optimization algorithm used to minimize the cost function. A machine learning model always wants low error with maximum accuracy. So, to decrease error, we will insert our algorithm that we're doing something wrong that is needed to be rectified. That would be done through gradient descent. The gradient descent function uses gradient descent to adjust the slope. This is our actual point, and this is the slope between our actual point to find the low error. So adjust the slope and intercept. This is the coefficient of our slope, and this is the intercept. Adjust the slope and intercept of a linear model. This is our linear model to minimize the mean square error by visualizing the prediction and various iteration. It shows the convergence process of the algorithm, showing how the predict line, this is the predict line, how the predict line gradually align. This is the first one and this is the last one, or it's better to say this is the best one, align with the actual data point. This process is crucial for understanding how machine learning models are trained to fit our data. Okay, machine learning usually use learning data. We need to minimize our error. To get pointer to minima, we need to walk some step. This is our step that are known as alpha or learning rate. If our learning rate is too large or too high, the parameter update can be excessively large, causing the algorithm to overshoot the optimal value. This can result in disconvergence or oscillation. Or our learning rate is too small. The parameter updates are very small, leading to a slow convergence and risk of getting stuck. So it's so important to find optimum learning rate. The learning rate is a crucial hyperparameter in the gradient descent algorithm, dictating the step size. This is our step size, and each iteration while moving toward a minimum of cost function. Understanding and tuning the learning rate is essential for efficient and effective model training. As you can see, when we use the big learning rate, you can see very high learning rate, our cost function increase. And if we use the good learning rate or optimum learning rate, as you can see in this figure, we we will have a low cost function. So it's so important to find an optimum learning rate in your model. Usually we show learning rate with this sign. So what is the M and what is the B? As I show you in this slide, M is our slope and B is our intercept. So the learning rate is denoted by this sign eta and determine the magnitude of update to the model's parameter, the slope n and the intercept b in linear regression during each iteration of gradient descent. So for the slope, m new equal m old minus learning rate and multiply dot delta MSE over delta M, and for the intercept new equal B old intercept old previous intercept minus learning rate eta dot delta MSE over delta B. It's so as I told you, it's so important to find your optimum learning rate to train your machine learning with high accuracy. Let's start to write our own Python code to show how we can determine our MSE with determine learning rate and other necessary things. So first of all, it's okay. I need to explain how to use gradient descent. For implement gradient descent, so it's necessary to randomly define initialized value, for example in this point random initial value, and update our value. After that repeat until slope equals 0, like the yellow point. A derivative is a term that comes from calculus and is calculated as the slope of the graph at a particular point. The slope is described by drawing a tangent line. For example, for this point, it's necessary to draw a line, tangent line, to the graph at the point. So if we are able to compute this tangent line, we might be able to calculate the desired direction to reach the minima. I mean this minimum point. So now we can start our Python code. First of all, it's necessary to import essential library like such as NumPy library and pyplot. Right. Import NumPy as np, enter, import matplotlib dot pyplot as plt. Pyplot module from Matplotlib, which is used for plotting and visualization of our data. Okay. After that, we need to define our gradient descent. Define a function named as gradient descent that take two arguments, x. First write gradient descent, x as an input data and y as a target value. Okay, after that we need to define or initialize the slope m curve as our slope coefficient and intercept b curve p current of the linear model to 0. So m curve equal b curve equal 0, and define our learning rate for the gradient descent algorithm. Learning rate equal 0.01, enter, and define n equal len x, store the number of data point in n, enter, and plt dot s scatter x y color of red, marker called plus, and line is equal 5. Plot the input data x and the target value y as a scatter plot with a red marker. Okay, and now initialize an empty list to store the predicted value y value for visualization at different iteration. So okay, start. Okay, so all y predict store. Okay, after that start a loop that will iterate 10,000 times for the gradient descent optimization. So we need to write for I in range 10,000. Okay, y predicted equal m curve multiply x plus b curve, and calculate. Okay, and then calculate the mean square error between the actual y value and the predicted y value, and MSE equal 1/n multiply sum y minus y predicted Okay. Incomplete input. Sorry. Underline curve B underline curve equals 0. It's better to write thing Control C. It's better to write in all of the thing in one cell and then start the function. Okay. Enter. After define MSE, we need to check if the current iteration number I is a multiply of 100. Print the current iteration number, slope, intercept, and MSE for debugging purposes, and also print the predicted Y value for debugging purpose. And also after that, append a tuple containing the current iteration number and the predicted Y value to the all Y predicted list. So we write this if condition. Okay. If I in if I send 100 equal 0, print f iteration I equal m b equal b curve and MSE equal MSE. Okay, after that print if iteration y predicted equal y predict forgot to put parentheses here. Okay, and enter all y predicted that append y predicted. Okay, after write this comment, it's possible for us to print the current iteration number, slope, intercept, and MSE for debugging purpose, and print the predicted y values for debugging purpose, and also append a tuple containing the current iteration number and the predicted y value. After that, it's necessary to calculate the partial derivative of the MSE with respect to the slope m square. So after this section, we need to write before doing anything. Okay. Calculate the partial derivative of the MSE with respect to the slope, and also calculate the partial derivative of the MSE with respect to intercept, and update the slope by subtracting the product of the learning rate and the partial derivative, and also update the intercept by subtracting the product of the learning rate and the partial derivative. So we write this code in d equal minus 2 over n multiply sum x multiply 1 minus y predicted. Okay. Let's copy this line. Change MD to YD minus, okay, sum y minus y predicted. Okay. Enter m cure equal m cure minus rate multiply md b cure equal b cure minus rate multiply yd. Okay, After that, and also to move this line. Okay, after this one also we need to iterate over each save iteration and its corresponding predicted y value by this command. For I y predicted in all y predicted into plt dot plot. After that, plot the predicted y value against the input data x and label the line with the iteration number. Plt dot plot x y predicted label if iteration I. Okay, after this section we need to plot the final predicted y value against the input data x in blue and label in line as a final iteration. So enter. Plt dot plot x y predicted color qual blue comma label equal final iteration. Okay, define legend plt dot legend. Okay, and plt dot show. Okay, after this section, define the input data x as a numpy array and also define the target value y as a numpy array. So need to define sample data, x equal np dot array. For example, 1, 2, 3, 4, and 5. Enter y equal mp that array 5, 7, 9, 11, and 13. After this line, we need to call the gradient descent function with x and y as an argument to run the gradient descent optimization and plot the result. So we write this command gradient descent x y. Okay, we need to check our code. Okay, define this one. Okay, if and now we run the code there. Okay, if I need to check. So okay, we need to modify the line. Also for this one, in Python it's so necessary to observe all of the things. Okay, and also define you can see this is the our slope m, the 100 iteration, and b, and this is the MSE as you can see, and this is the y predicted, and as you can see MSE decrease by increasing the iteration. Decrease, for example, the 100 iteration, the MSE is 0.477, and the next one is 0.24, and until the last iteration you can see MSE is 1.04, E minus 27, and the different you can see there is no significant difference between from 8,900 iteration and until the end, but the previous one you can see this is 1.29, E minus 26, and then decrease also. This is our final, and you can see our predict y value is exactly same with the value we input in our code 7, 5, 9, 11, and 13. You can see here, after the after uh, 5,700 iteration, the y predicted became similar to our actual y, and also you can see MSE decrease until this number. And also in here, in here you can see lots of line until the blue line show the minimum error in this tutorial. I hope you enjoyed this tutorial and learn lots of things about the gradient descent method in machine learning. Please subscribe my channel, follow us to learn lots of things. Thank you for taking your time. See you